Hello everyone and welcome to this presentation. I am Dr. Dimosthenis Kifokeris and I'm assistant professor at the Chalmers University of Technology, Sweden, and I'm going to present to you a blockchain, proof of concept and pilot testing of a blockchain application prototype for construction logistics in Sweden, which I co-authored with Dr. Christian Koch, a professor at Aarhus University, Denmark. So the agenda for this presentation consists of the research question, which prompted us to do this research, the underlying theory that we used for our study, our research, the elaboration of our research method, which consisted of literature review and an empirical part, then the actual elaboration on the literature review and the empirical part themselves. And in the empirical part, we will talk about the conceptualization, development, and testing of our proof of concept, namely blockchain. And finally, we will end with a discussion, conclusions, and some thoughts about the future. Common construction logistics problems in the Swedish context, like for example flow disintegration, imprecise data retrieval, and accounting misalignments among supply chain actors, motivated our research question, namely whether a blockchain solution for integrating the economic information and material flows in construction supply chains and logistics within the Swedish context could exist. And to answer the research question, as we will see in this presentation, we conceptualized, developed, and tested a proof of concept pilot, BLogCHAIN, which is an abbreviation for Building Logistics Blockchain. This was developed and tested in 2 iterations in late 2020 and early 2021. It was based on a previously conceptualized sociomaterial blockchain solution for integrated logistic flows, and we focused on a single project in Sweden in order to acknowledge institutional specificities. The theoretical background of our study consists of 2 parts. One is the theory of sociomateriality, which entails that the material and social aspects of digital technologies are inseparable and fused in practice. And the other part of the background has to do with the integration of supply chain and logistics flows. In the literature, one can find a lot of research regarding the supply chain and logistics flows. There is the material flow, there is the information flow, and then there is the flow that has to do with financial or economic transactions. In our particular mode of understanding, apart from the material and information flow, the flow that has to do with transactions that not only have to do with monetary exchanges, but also integrate things like data on prices or invoices, makes a single flow, which we deemed as the economic flow. So in this part of our theoretical background, our focus was on the way these flows could be realized in downstream logistics. As such, taking into account the theoretical and empirical studies in the particular Swedish context, we came up with this generic downstream logistics setup. Obviously, not all projects have this kind of setup, but we think that this setup kind of encapsulates what is the deal with downstream logistics in a generic construction project in Sweden. As we can see here, I won't dwell in this flowchart too much, but we can see that there is a disintegration of flows. There are a lot of loops. We can see that the supply chain actors are generally disengaged with one another, and in general, this setup shows that the logistics processes are not streamlined enough, and that the flows, the material, the economic, and the information flows are generally disintegrated. Combining our theoretical themes, we arrived at the sociomaterial take on blockchain for logistics with integrated flows. This is a permissioned private digital ledger for partially decentralized peer-to-peer information and economic transactions in a project-specific network of supply chain actors. Its digital ledger databases are permanent and append only, and the historical data that can be accessed by across all the network nodes is updated through consensus. A reduced but existing need for in-between transactional verification is there since this is a permission system, and it is based on proof of authority algorithms which feature identity as a stake. With this system, we create power shifts in the network in line with the sociomaterial autonomy control paradox. And the flow integration can be brought about by transactions in the economic flow, like for example, issuing invoices, which are connected to events in the information flow, like for example, placing purchasing orders, and or events in the material flow, like successful on-site material deliveries. The concept of this sociomaterial take on this blockchain solution can be shown in this flowchart. As we can see now, the whole setup is much more streamlined, and the flow integration, as described before, can be brought about by smart contract predefined clauses. These four particular clauses are whether the purchasing order is okay, whether the delivery order is okay, whether the gate control has been passed and there has been a correct on-site placement of the incoming goods, and finally whether the quality control check of this incoming goods has passed as well. The predefined actors for this consensus check, at least in the way we conceptualize it at this point, were the project clients, the logistic consultants that are employed by the project clients, the general contractor, and the suppliers. So having this theoretical background, I can now show the research methods we used for this study. First, we did a systematic literature review, which utilized the concept-centric framework augmented with units of analysis. And then we moved on to the empirical part of our study, where we combined the sociomaterial methods of zooming in and out, having meetings and interviews, doing observations, and also mapping the participants of our project. In particular, these sociomaterial methods were blended together in various stages in order to realize the following steps of the empirical part of our study, namely the mapping of the Swedish context, finding a suitable test site and willing testers to participate in the project, developing and field testing the actual application pilot, namely BLogCHAIN, and finally evaluating the test results. In our literature review, we focused explicitly on blockchain research for construction logistics. We found out that core blockchain properties can generate most of its envisioned benefits for construction logistics, like, for example, a reduction in the accounting rework. There has been a major research focus on smart contracts, but the studies have been this far mostly conceptual, with no use cases yet. Only a few studies researched social or socio-technical issues, and a focus on sociomateriality and flow integration could be found this far only studies for the Swedish context. There are barriers in adopting blockchain for construction logistics, like for example, a limited engagement with this technology in the construction industry, and there are also security issues like a presumptive mistrust with a potential abuse of the properties of blockchain as a technology. Moving on to the empirical part of our research and the preparation of the tests of our application. The testing period was from the October to December of 2020 at the construction site of a school building in Sweden. The logistics constellation included a large contractor internalizing logistics. The public client was the local municipality, and we arrived at this project at the early construction phase. The main contractor was one of the four biggest Swedish construction companies, and the main deliveries at this point in time were mostly materials, namely concrete, aggregates, steel, and lighter materials like wood. We established a correspondence with a site manager from the contractor side and also one operative in each supplier. So trying to realize the concept that I described in a flowchart earlier into the development of an actual pilot, we actually asked from a colleague feedback through semi-structured interviews. Through this feedback, we found out that the contractors and suppliers accounting systems were disintegrated and passed through different control nodes. The clients were not active in overviewing logistics processes, and established on-site work practices actually reduced our scope of implementation. And so more demarcated smart contract clauses would have to be conceptualized. And in the same vein, our proof of concept should be simplified. The scope after these simplifications and demarcations would be not in the whole downstream construction logistics segment, but rather on the issuing of order confirmation from the suppliers to the acceptance or not of this supplier's invoice issued after the delivery by the contractor. As such, the simplifications that we had to do in our initial conceptual vision had to do with the engagement of relative actors in the supply chain, like the clients, which were now non-existent. And in that way, the simplification of the people, of the actors that would be involved in the consensus checks, and also the demarcation of the smart contract clauses. Now we had some mandatory smart contract clauses like the purchasing order confirmation and its acceptance, the acceptance of the delivery receipt, and the acceptance of the invoice, but also some optional smart contract clauses that would not actually stop the flow of the blocks in the blockchain, but would mostly serve as checkpoints within it. These optional clauses would be the transporter's notification, whether the goods were delivered in the right place, whether the goods labeling was correct, and finally, whether the goods packaging was undamaged. So following this updated conceptualization, we actually moved on to the development of our proof of concept prototype for both the desktop computers and smartphones. Here, there are some screenshots of BLogCHAIN for smartphones. Without wanting to tire you too much with technical details, I will only say that the blockchain infrastructure on which this application was based was Hyperledger Besu, and we used MetaMask in order to create the accounts of the particular roles and actors for this application. So in the first iteration of tests with this proof of concept, the transactions were infrequent and spread during the testing period. They were mostly initiated by the concrete and the aggregate suppliers. This infrequency was mainly due to the construction phase and, of course, due to the COVID-19 pandemic crisis. One of the suppliers already deployed an automated digital accounting system, so they didn't test blockchain, so we had one supplier less. And we had an established continuous correspondence with the testers in order to hands-on monitor the tests and offer continuous technical support. So the positive comments of our colleagues' feedback that we got after this first round of tests was that through blockchain, the tampering with past data was indeed avoided. And since blockchain was a single platform, there was no work needed to consolidate different ledgers. Moreover, the logistics flows were indeed integrated, and this led to process streamlining and fostering trust and transparency. However, a negative comment was that there was an almost absent previous engagement with blockchain, which made it more difficult to pitch the technology's potential. And when it comes to proposals for future improvements, this had to do with the conditional involvement of the client and or the logistic consultants, which in a way approached the first initial conceptual vision we had for this proof of concept, to add a transporter notification function, and also to accommodate different supplier roles, for example, the sales manager and the invoice issuer. Moving on to the discussion and conclusions of the study, blockchain does have a great potential for construction logistics in Sweden, but more work in research and empirical grounds needs to be done still. Blockchain does support transparent coordination, which in turn can lead to a reduction in quality defects, for example, waiting times and on-site work interruptions. Enabling online construction progress surveillance can provide clients with valuable knowledge, especially if the clients have an active role in the blockchain network. And when it comes to the compulsory versus voluntary smart contract checks, it is maybe best to keep most checks voluntary to avoid unnecessary bottlenecks, as was the case in our concept as well. Finally, when it comes to the system integration through suitable APIs, it is quite crucial for fostering the coordination and trust among the participating actors. Some final pointers. The second iteration of development for the blockchain took part after the first round of tests in the beginning of 2021. And the results after the second testing iteration, which took place in February 2021, are to be published soon. Unfortunately, they were not part of this paper, so I cannot present them here. When it comes to future recommendations, we're thinking of utilizing cryptocurrencies for monetary transactions within the system, integrate blockchain with the Internet of Things, like for example, side gate control systems and GPS trackers, integrate it with data warehouses in order to check the creditworthiness of clients, have an aftermarket function in order to monitor post-order transactions, and integrate it with our AI, machine learning, and deep learning in order to identify performance patterns across the supply chain, be more efficient in mining through machine learning training, create forecasts for market analysis, and siphon data for knowledge extraction. That's all for me. Thank you for attending this presentation.